Welcome back, Life Science learners, to our second installment for today. Just recap on what we've just looked at. So in our first segment, we were looking at how we represent data. So we've looked at different types of data. We've looked at how to collect information. We also mentioned how information could be processed and put into a table. And we know that tables are important. It's important in organizing that information. However, we know that tables are not the best way to see that information. Often, a scientist will require a visual stimulus or something that's an illustration that you can see trends or see information. So, the best way to do that is to present that information in a graph. So we've got to be able to know what are the different types of graph and what is the best way to represent information and which type of graph. So let's recollect on the types of graphs that you've been exposed to. So we know what line graphs are, and so line graphs tend to show how information is shared on a continuous basis. We also know that there are bar graphs, and bar graphs tend to be information that is non-consistent but can be illustrated, showing you the change in. And I mentioned this earlier on, a bar graph could be used to illustrate information where we talk comparing an age cohort to a different age cohort, or males and females, or the average rain in the year 2019 compared to the average rain in the year 2020. So those are comparisons where a large group can be compartmentalized into different segments. So we use a bar graph. We also can use histograms, which shows how information is continuous, but grouped information being continuous. So a histogram is slightly different to a bar graph, where we see continuous information being illustrated using bars. We also know that there is pie charts, and often we scare away from pie charts because it requires a bit of math and using a protractor to measure angles and to calculate how these proportions are illustrated in a pictorial. So today we're going to look at, in this segment, we're going to look at how to draw a line graph and how to plot a pie chart and use the information of both to be able to draw bar graphs and histograms. So let's get straight into looking at what graphs are. So graphs and charts basically condense large amounts of information into a format that is easier to understand, showing important points clearly and effectively. Line graphs show the relationship between two types of information where the independent variable is continuous. Line graphs are useful in showing trends over time and are often used for biological data. So as I said, it's often the independent variable which is continuously occurring. We place that on the x-axis and we look at the trends that happen over a period of time or over a period of temperature, where the temperature is changing. So we see progression from one to the next. We also know that bar graphs show different categories of data, as I mentioned, and are used when the independent variable is not a set of continuous numbers or continuous groups. We refer to that as being discontinuous data. They are best used to compare values across categories. So example, the average age of individuals in grade 10 compared to the average age of average number of individuals in grade 11 that are 13 years or 14 years. I would hate to think that someone is 13 or 14 in grade 11, but probably grade 7 or 8. So we're looking at a group of learners in primary school that are aged between, say, 13 and 14. So we would group that information together and we'd compare that to another group of boys in that age category. So here we're separating information. It's not continuous, and we're not able to draw trends, but we're able to group them into a category and present that as a bar on a graph. Okay, cool. Histograms have connected bars displaying continuous data, meaning the information from one leads to the next group. They're used when the values of the independent variable are continuous but fit into categories or groups that follow on after each other. So the example would be the average rainfall in Jan, the average rainfall in February, the average rainfall in March. So that would be measuring the amount of rain that has fallen for 30 or 31 days and putting that into a bar and we continue that with an attached bar, and we refer to that as a histogram because the information here is continuous with each other. Okay, the fourth type of graph are pie charts, and these are basically circular charts that are used to compare parts of the whole. So we say that that's an illustration of how different proportions make up the complete set of information. These are divided into sectors that are equal in size and to the quantity represented. So we say proportionately. They are often used for discontinuous data. And we'll look at examples of how a pie chart is plotted for in. Let's see how to draw a line graph in life sciences. So the first step is identifying what the dependent and the independent variable is. And we look at the information, and that's established by usually looking at the table. So if you've got the table, and you know that the table we've just looked at has the independent variable on the vertical column, and we identify that first, and that's important to us, identifying where to place that. We then look for the dependent variable, and this is the variable or the factor that is being measured, that is used to measure or to determine the conclusion of an experiment. It could be the temperature in degrees Celsius, and we'll look at that in the table that I've placed on the next slide. So let's look at an example of that. The independent variable is that the variable that the investigator is changing or manipulating. The dependent variable changes as the independent variable changes. So the time in hours is the example of an independent variable. So let's move on to the next slide. So here we've got a table which illustrates the time, and we've looked at how that temperature changes over a period of time. We know that here along this column we have the independent variable, and that's easy for us to identify. And here we have the variable that is changing, and we refer to this as the dependent variable. So we've clearly identified from this table the different variables, which is firstly important to placing them on the axes. The second step is to draw a set of axes and label the x and y axes on the graph. The dependent variable goes on the y-axis, and the independent variable goes on the x-axis. Include the unit in each label. Example, temperature in degrees Celsius and time in hours or minutes. Do not forget to label the axes. And often I have learners that ask me, well, how do you remember which is the independent and dependent variable and which axes they go on? So I often use this as a simple illustration. So remember the word independent, so I'm writing that here, I. If you see my I, that's independent. So that goes on the x-axis. And the word dependent starts with the letter D, so that goes on your y-axis. So if you remember independent and where the capital I falls on, and that would be your x-axis, and the dependent, the vertical line in that, means that the dependent should be on your y-axis. And that's one simple way of helping you remember where to place them. How to draw a line graph would then require you to be able to draw a set of axes and choose a scale. So choosing a scale is important. For you to be able to choose a scale, you must look at the range of your results or range of values in a table. And often you look at the lowest value and the highest value, and you try and fit those proportionately on your x-axis or your y-axis. And so scale refers to the proportion in which you represent the units on the x and y-axis. So you simply cannot take a value from the table and write that down onto your x-axis. These values need to be proportionately in scale to each other. So if you look at my graph, you can see that I've got the time in intervals of 2 units, and this indicates the scale being consistently 2 units increasing as we move along the x-axis. On the y-axis we have temperature, and we can clearly see that temperature is in units of 5, and the proportion of the scale is in regular units of 5. So that's the first thing we need to do, is draw the axes. We've labeled the axes, so we've got a mark for the unit, and we've got a mark for labeling the y-axis with the units. So let's look at the next step. Step 3, we chose the scale, the x and y axes have been labeled. Now we make sure that we included the scale, done. We included the highest number from the table, and we've also ensured that the values are not directly plotted from the graph, but we've taken them and we've put them into a scale, and we refer to that as using a scale unless otherwise stated. So we have to have the values scaled down correctly. Let's look at step 4. How do we plot these points? So we place a dot at the point where the two values for each result intersect or meet. In the example, which is on the next slide, the point where 5 hours and 24 degrees intersect on the graph is indicated by a second dot on the graph. You've got to plot all these points using information from the table. So I've done that for you, and clearly, so I've looked at the first point being 5, so I've used my ruler and I've plotted that up this way, and on the y-axis we've got at 5 minutes the temperature was 25 degrees, and so that's where it intersects, and I place a simple small dot that makes it clearly visible for me. The next intercept would be at 8 minutes, and the temperature was approximately, I'm going to go by that, and that's what it is there. So it's probably 9 minutes, and the temperature was around that. And so I will place a dot at these and move on, referring to my table, plotting these points. Okay, let's look at step 5. Now we've got to join these dots using a ruler until all the dots have been joined in sequence. Now I know that sometimes your teachers encourage you to use a freehand, which is simply going and connecting the points together. I'm going to go back to this and I'll show you how I would have done that. So you follow the dots and you connect them freehand. And this could be done in science. I know that you're encouraged to use a ruler to do that. So look at the instructions. You either use your ruler, and if you don't trust your hands, and if you've got hands that do not draw straight lines, then do them with a ruler. The next step would be give the graph a heading and a caption. Anything, a table or a graph without a heading means it's nameless, and you want to give that graph or a table a heading. The heading has to include both the variables, meaning that it must have both the independent and the dependent variables. If we go back to this table or this graph, it's going to be a graph showing the change in temperature over a period of time. Okay, so I've included both the dependent variables as well as the independent variables in my heading. So let's look at that again. So in this case, it's the air temperature, and the time period over 24 hours must be mentioned. The sixth step would be give the graph a heading, and as I said that, and it should include both the variables. Okay, we're going to move on to how that would look. Sometimes you get two lines that are being represented, so it would be the temperature for two different individuals. And it's important that if you had to plot this, you would need to give this a key. And a key, or in some textbooks, we refer to that as a legend, would be an illustration that allows an individual to be able to identify the difference in this case between the one reading, which is for temperature, and in the other reading for rainfall. So if the red line represented rainfall, we would need to indicate that in the key. So keys are important, and it makes the interpretation of that information much easier. So guys, we've looked at how to present information in a line graph, and we're going to use those principles in the next segment to plot a pie chart. You guys have done well. You've been attentive. You guys deserve a little break. I'll catch you at the end of the break. Hang in there and tune in soon.